Okay, in this video we're going to be looking at two exam style questions that you'll probably see on some exam in the future if you're doing calculus. These two exam questions will all be about just derivatives and something you can do with them instead of just finding the derivative, because that's too easy. So this first question, find a tangent line of f of x equals x to the fourth plus 3x minus 10 at the point 1 comma negative 6. Okay, so usually tangent line usually means derivative, so let's take the derivative of the function. Right, we just use the power rule and for both of the terms, and then the negative 10 goes away because it's just a constant. We don't care about that when we're taking the derivative. Now we want to evaluate it at 1, x equals 1, right? So it's just this equals 7. This 7 is important because it gives us the slope, or m, right? Now we want to find a tangent line, and we can use this fact that we know the slope, and we also know the point, right? Point slope. I'll just write out the general point slope equation right here, where x and y, x naught and y naught are just the point. So it's just y minus negative 6 equals 7x minus 1. This becomes positive, and then if you want an slope intercept to make it look more nice, let's see, like this, and then the final answer is y equals minus 13. This is the final answer, and then we're going to look at here. If I put in the two things we found, this is the function, this first one on the top, this green one, is that function. And then this is the slope of the tangent line. We see that right here. Tangent line. At exactly this point, 1 comma 6, this is the line that just touches that one point and nothing else, right? I'm going to keep zooming in on this just to show you that there is going to be a small difference as we zoom closer to this point. Let's zoom a little bit here. Right, see? But as we get closer to the point, it's just going to touch it barely. So that just shows something we can do with derivatives. We can find tangent lines, and we can find the equation of them pretty easily. This is the second question. The position of a particle is moving along the x-axis at time t. Is x of t equals sine x cosine x? What is its velocity at time t equals pi over 3? So this is kind of like a physics question for those people who know a little bit of physics. We have a position, which is, I guess, some people say s, some people say r, right? This is the position, or in this case they say x, right? X. How are this and velocity related, right? How are these related? Well, the position, if you take the derivative of position with respect to time, you get the velocity. So let me write this right there. So we want to find the derivative of x like this, right? And the way we do this is, let's see, how do you find the derivative of a product? Well, we have to use the product rule. What the product rule says, I'll write it off here. So this is given two functions, and you want to find its derivative. It's just the derivative of the first plus the times the second plus the first times the derivative of the second, right? It's kind of like switching. So that's what we want to do here. We want to find the derivative with respect to time of the first function, and then cosine, where these should be t, I think. Yeah, these should be t. And then sine t, and then find a derivative with respect to t of cosine t. Now we can easily just evaluate these derivatives, right? This is cosine from our rules. And then this is just sine t, and this is just negative sine t. In other words, it's cosine squared t minus sine squared t. Now we would just want to see what it is at time equals pi over 3. I'm going to scroll down a little bit just to give me more space. So the derivative of this at pi over 3 is also the same as the velocity at pi over 3, which is just plugging it into the value, cosine squared of pi over t, or pi over 3 minus sine squared of pi over 3. And then you have to know these values because there might be questions where you don't get a calculator, so you can never figure it out. But you have to know that the value of cosine of pi over 3 is 1/2. Right, so it's actually 1/2 squared minus, and this one has to be 3 over 2 squared. I'm going to keep scrolling down here. And then we can just simplify this. This is 1 over 4. This is 3 over 4, which is equal to negative 1/2. And this is in units of something like a distance over a time, right? So if I were to say, if t is in seconds and the position's in meters, the velocity should be minus 0.5 meters per second. Sometimes the question will say what the units should be. If they give you meters and then they say times in seconds, the velocity should be meters per second. If they say the distance or the position would be in miles and the time is in hours, then it'd be miles per hour.